Okay, so in this video we're going to find the log of minus I. So here we can see the notation, we've got the capital L. So with this capital L here, we're looking for the principal log. Because when you're dealing with complex numbers, there is infinite solutions. So I'm going to explain that a little bit on the diagram here. So look at what we've got. So minus I is here. Now what we can do, travelling from the real axis, that's the imaginary axis, our minus I, that's our complex number here, that's our Z equals A plus BI, where A equals 0, B equals minus 1. Our argument for this goes all the way around to there. That is one solution. We could also go around twice, that's another solution, and so on and so on. We could also go the other way around. So that's why we call it principal log. So what we're looking for is the one solution. And the one solution for the principal log is within the set of minus pi, theta, less than and equal, positive pi. So that's where the argument needs to be. It needs to be within that boundary there. So inclusive of positive pi, but not touching negative pi. So let's go on now. Let's try and work out this log of minus I. So how do we do complex logs? So complex logs is log of Z equals principal logarithm of the modulus of Z plus I times the principal argument of Z. Now notice we've got the absolute value brackets here, as we're finding the modulus, that will always be a positive real number. And the argument, obviously there we don't need the absolute value numbers, that can be a positive or a negative. So in this case, our Z is minus I. So what we're looking for now is the principal log of minus I equals, now principal log, now what is this, Z? The absolute value of this is just 1, isn't it? Because we've got R, so R equals square root of A squared plus B squared, and taking these ones here, R equals square root of 0 squared plus minus 1 squared, which equals 1. So we've got the log of 1. We could take away the absolute value because we know 1 is positive, and I, argument of Z. So if we go round, take this inside one here, we can see that that angle there is our theta. So let's put that down here. Our theta equals 3 pi over 2. But this, if you look in here with our parameters negative pi and pi, this doesn't fit. So what we need to do is get an argument of theta, or an argument of, of our Z that fits into these brackets here. So instead of going this way round, we can go the negative way round and go this way. So there, we're just turning a right angle. We can just say that is negative pi over 2. That will be the same. So we have to work on that as negative pi over 2. So I negative pi over 2. So just to reiterate this one here, our theta is 3 pi over 2. Keep going. We can keep going round. What we can say is that our argument, notice the lowercase a, is 3 pi over 2 plus 2n pi over 2. Just plus 2n pi, where n is an integer. So here we're choosing our integer here to be minus 1. So that'd be minus 2 pi. So 3 pi over 2 minus 2 pi gives us our negative pi over 2. Okay. Now let's just simplify this up a little bit more. So log of 1 is 0 plus I minus pi over 2. And simplifying it even more, we're just left with minus I pi over 2. And that is what the log of minus I is. Okay, thanks for watching.